So this is our midterm exam corrections. Starting with number 5, we were asked to convert from binaries to decimal, and we were giving the binary representation 10111.10111. So starting off with the integer, we are going to use our twos chart to fill in. That way we know what we're multiplying by. So starting off, we have 2 to the 0 times 1 equals 1. 2 to the 1 times 1 equals 2. 2 to the 2 times 1 equals 4. 2 to the 3 times 0 equals 0. And then 2 to the 4 times 1 equals 16. All these together add up to 23, which will give us 23 for our integer part of the binary to decimal conversion. Starting off with the fractional part, we have 2 to the negative 1 times 1. Since we are going into the fractional, we move into the negatives. And then we have which equals 0.5. Then we have 2 to the negative 2 times 0 equals 0. We have 2 to the negative 3 times 1, which equals 0.125. Then we have 2 to the negative 4 times 1, which equals 0.0625. Then we have 2 to the negative 5 times 1, which equals 0.03125. So all these added up together gives us 0.71875, and that will be our fractional representation, which are our fractional representation, and converting this to the binary representation. For number 7, we have 135 base 6 to base 10 to base 2 to base 8. So starting off 135 to base 10, what we do first, like I said, we're gonna put 0, 1, 2 for our powers of 2s chart. That way we know what we're multiplying by, just because we're converting to base 10. So we got 6 to the 0 power times 5, which is 1. That gives us 5. Then we have 6 to the 1, or 6 to 1 times 3 gives us 18. Then we have 6 to the second power times 1 gives us 36. All of these added together gives us, all these added up together gives us 59, and that is base 10 for 135 base 6 to base 10. Going from base 10 to base 2, we take 59 and we do our division remainder method. So here we have 59 divided by 2 gives us 29 remainder 1. 29 divided by 2 gives us 14 remainder 1. 14 divided by 2 gives us 7 remainder 0. 7 divided by 2 gives us 3 remainder 1. And 3 divided by 2 gives us 1 remainder 1. And then lastly, we have to divide 1 divided by 2, which gives us 0. And then the 1 to be drawn over here because it's the last one. And then we read from bottom to up. And from there we get 1, 1, 1, 0, 1, 1. And that is 59 base 10 to base 2. And then lastly, we were asked to go from base 2 to base 8. We know that in order to go to base 8, we need it in the binary representation first. And we also use three digits instead of 4, which is hexadecimal. So with these three digits, we start from right to left. We have 110. Starting off, we know that's 3. And for the second set of binary digits, we have 111, which we know is 7. This both equals 73 together, and that is base 2 to base 10, or 111011 base 2 equals 73 base 8. Sorry, not base 10. Then for 10 and 11, the sign magnitude of positive 38 is 001001110. And the sign magnitude of negative 38 is 101001110. I had these switched around, but I did know, but I must have forgot. 1, or whenever the equation starts with 1, it will represent negative, and vice versa with positive. Whenever it starts with 0, it will represent positive. With number 14, we have to identify our key figures of computer science history. Starting off, we have Charles Babbage. He was an English mathematician, and he originated the concept of the programmable computer. Ada Lovelace, she was a skilled mathematician who was the first programmer and also extended Babbage's ideas. Joseph Jacquard, he created the Jacquard's loom, and he also, sorry, give me 1 second. Oh, and also he created the punch analytical engine. Sorry. Herman Hollerith, he was the father of modern machine data card processing. He also created the punch card machine. Dr. Mark Dean, he created the microcomputer and tablet, and he also furthered these. He also helped further these like microcomputers, such as like hard drives and things of that nature. And then last but not least, we have Dr. Evelyn Boyd Granville. She helped create the computer science software for NASA. And last but not least, we have number 15, and we were asked to perform binary arithmetic for 38 plus 5. So for 38, we know we have to, in order to go from 38 base 10 to base 2, we have to do division remainder. So we know that 38 divided by 2 is 19, remainder 0. 19 divided by 2 is 9, remainder 1. 9 divided by 2 is 4, remainder 1. 4 divided by 2 is 2, remainder 0. And 2 divided by 2 is 1, remainder 0. Then 1 divided by 2 is 0, remainder 1. That will give us 1, 0, 0, 1, 1, 0 for the binary representation of 38. For 5, we do the same thing. We have 5 divided by 2 equals 2, remainder 1. 2 divided by 2 equals 1, remainder 0. And 1 divided by 2 equals 0, remainder 1. We read from bottom up for both. And then our binary arithmetic would be adding. So 1, 0, 0, 1, 1, 0 plus only the 1, 0, 1 right here. You just fill in the rest of the zeros in order to complete. So 0 and 1, we know we get 1. 1 and 0, we know we get 1 again. 1 and 1, we get 10. Just draw the 0 down here and add the 1 to the next column. Then we have 1 plus 0 plus 0, we get 1. And 0 plus 0 is 0. And then 1 plus 0 is 1. So binary arithmetic would pretty much be this whole, little addition here.